Okay, let's unpack this. When we talk about future mobility, the conversation usually, well, it sticks to pretty predictable paths, right?
Self-driving electric cars, maybe drones.
Exactly. We're sort of conditioned to think about friction on asphalt. We think in terms of, wheels or wings.
And that's precisely why the source material you sent over is so compelling. It just completely breaks that mold.
It really does.
Instead of just optimizing what we already have, Kawasaki has, well, they've abandoned the wheel entirely and taken us straight to the stable.
A very, very high-tech stable housing the Kawasaki CORLEO.
Yeah.
This isn't just a sketch. This is a legitimate hydrogen-powered, AI-guided robot horse that's apparently moving toward production.
It is.
So for this deep dive, we're going to extract the nuts and bolts of this thing. Why trade wheels for legs? How are they powering it? And, when can we actually expect to see it?
And it's important to stress right up front, this is way beyond a simple concept. It was shown at Expo 2025, sure, but the latest info confirms it's slated for real-world production.
So this is Kawasaki making a serious play.
A very serious play. They're positioning themselves not just in robotics, but in defining what comes next for extreme off-road travel.
I just find the fusion of ideas here incredible. Let's jump straight into the power source, because this is where they've made a really distinct choice. Trading hooves for hydrogen.
It's fascinating. The choice of a 150cc hydrogen engine in a world that is so saturated with battery development, committing to combustion.
Albeit a clean combustion.
A zero-emission combustion, exactly. But it's still a gold move.
Okay, so a 150cc engine, in the grand scheme of things, that's relatively small for an adventure vehicle. What does that tell us about its performance? Are we talking speed here?
No, not really. It definitely leans toward torque and endurance. This robot isn't built to be a speed demon.
It's built for something else.
It's built for sustained, reliable movement across really hostile environments. And the hydrogen choice just reinforces that. Well, think about batteries. They're heavy. They take a long time to charge, which is a deal breaker if you're in a remote area.
Right, you can't just plug it in.
Exactly. Hydrogen lets you refuel in minutes, not hours. And you get a much better power-to-weight ratio for the kind of demand for articulating legs you're going to put on it.
So the fuel, which is stored in those sleek rear tanks we see in the concepts, it's doing two jobs at once. It gets them to zero emissions, which is critical, but it also delivers the actual operational efficiency you'd need for a machine like this.
Precisely. They are using clean energy not just as a talking point. It's a practical enabler for this kind of high-demand performance.
So it sounds whimsical, robot horse, but when you dig in, you realize it's about solving a real logistics problem in places where other vehicles would just fail.
Exactly. Where traditional engines or even big EV platforms can't work because of refueling or just, sheer weight.
Okay, that sets the stage perfectly for the physical design. They've solved the power problem. But the locomotion... This is a whole other challenge. Let's get into that. The mechanical genius of these four legs.
Right.
Why legs? Why not just the high clearance wheel systems that Kawasaki is already famous for?
The sources are really clear on this. Legs solve a problem wheels can't, which is articulation over asymmetrical ground.
Meaning?
The design is specifically engineered for trails where bikes bail. That's the quote. Wheels need a continuous surface. Legs can step over things. They can adjust height, shift the center of gravity on the fly.
But that sounds mechanically so much more complex than an axle.
Oh, it is. Exponentially.
Yeah.
And that's why the details on the back-end mechanics are so important. This is where you see the Kawasaki heritage really shining through.
The rear legs.
The rear legs. They're designed for raw power and absorbing huge impacts. The sources describe them as being able to handle, rocky cliffs and ice pits.
And this is where we get that great technical analogy. The source says the back legs function like a boss on a motorcycle swing arm. Can you unpack that for us? What does that actually mean?
Okay, yeah. So think of a motorcycle swing arm. It's the part that connects the rear wheel to the bike's frame.
Right.
Its job is twofold. First, it gets the engine's power to the wheel. Second, through the shock absorber, it manages enormous vertical hits like landing a jump without losing traction.
Got it. So applying that to the CORLEO's back legs means the whole joint and suspension setup is engineered to take those massive shocks while still pushing forward.
Exactly. The rear legs are the powerful, stable engine thrust managers. They provide the brute force you need for climbing or just crossing really chaotic ground.
So that's the foundation.
That is the foundation. But the CORLEO still has to decide where to put those powerful feet. And that's where the front legs come in.
Okay, so we're moving from proven mechanical brawn in the back to the cutting-edge intelligence up front.
Correct. The front legs pivot smoothly, and they're guided entirely by AI.
That's the brains of the operation.
Absolutely. This AI is processing the environment in real time, mapping, as the source says, every gnarly twist, and then figuring out the best place to step in a fraction of a second.
So it's not just reacting, it's anticipating.
It has to. It uses sensor data to anticipate and dynamically adjust the gait before the weight shifts. It's proactive, not reactive.
That is a fascinating dual system. You've got raw, stable mechanics in the back, born from motorcycling, and then this complex AI-driven navigation up front.
It promises a level of stability that, wheeled platforms just can't match on that kind of terrain.
And all of this still has a rider on top.
It does. Which is why the relationship, the human-machine interface, is so critical.
The human-machine vibe, as they call it, and the control system sounds so intuitive, you just lean to steer.
Yeah, the sources are clear. No reins needed. They're aiming for something seamless. The human provides the high-level direction, I want to go over there, and the AI handles the nitty-gritty of how to get there safely.
So the rider is more of a guide than a micromanager of 4 separate legs.
Exactly. The whole goal is to make the adventure safer by letting the machine handle the immediate dangers of the unstable ground. The robot executes, the human directs.
Makes perfect sense. Okay, so we have the concept, the power, the mechanics. Now for the big question, the roadmap. When is Kawasaki actually promising to deliver this?
Well, let's first remember the mission. This is for traversing rivers, jungles, what they call total chaos.
Unlocking terrain.
Unlocking inaccessible terrain. And for something so radical, their timeline is.
Yeah.
It's surprisingly aggressive.
It is. They've laid it all out.
They have. Phase 1, which is all about refining the AI and the movement, involves VR test drives.
The simulations.
Right. And those are slated to drop in 2027. Which makes sense because getting that quadrupedal gait right is a massive challenge.
Then comes the big public debut.
Expo 2020, which the source material says is scheduled for 2030. That's their moment to show off a fully functional, market-ready concept.
And from there, to the consumer, the street rollout.
Which is the critical phase. They expect, and I love this phrasing, herds of CORLEOs to start hitting the streets by 2035. Wow. That is a very firm and very rapid timeline, especially when you think about the hydrogen infrastructure challenge alone.
And that's the big question, isn't it? 2035 is just around the corner, technologically speaking, for a product that needs brand new manufacturing and a fuel network that barely exists. Is that realistic?
It's an ambitious bet. It absolutely is. The price is TBD, of course, but the sources cite huge public enthusiasm. The desire is there.
But the logistics.
The logistics are the real hurdle. The speed of the rollout is tied less to Kawasaki's own ability to build the robot and more to the external world's ability to support it.
If this were battery-powered, 2035 would feel totally achievable with the existing grid.
Completely. But by choosing hydrogen for those performance reasons, they've tied their own success to a global energy timeline that's pretty much out of their hands.
That's the key trade-off, then.
It is. They prioritize performance, zero emissions, rapid refueling. But that choice brings this massive dependency with it.
When you connect it to the bigger picture, it feels like this is, well, it's a serious attempt to show a viable alternative to wheels.
It's more than an attempt, I think. It's a demonstration. It successfully combines articulation, green power, and AI to open up new possibilities.
So it's Kawasaki leveraging everything they know from decades in motorcycling.
Then applying it to the ultimate mobility challenge, mastering 4 dynamic legs in the wild. It shows us where high-end robotics is heading when it fuses with mobility.
They're not just improving a vehicle, they're trying to define a whole new one.
Exactly. They're creating a platform optimized not for the city, but for conquering the most demanding, unpredictable places on Earth.
Truly fascinating to watch this unfold. Okay, let's quickly recap the key takeaways for you.
Let's do it.
We've learned the CORLEO is a hydrogen-powered robot horse, and it's moving from concept to serious development. Power comes from a 150cc hydrogen engine, picked for zero emissions and fast refueling.
Mechanically, the brilliance is in the leg design. The back legs use motorcycle swing arm geometry for power and impact absorption, while the AI-guided front legs handle the smart navigation.
And the timeline is fast. VR test drives in 2027, a big debut in 2030, and then those herds of robots hitting the streets by 2035.
Which brings us to a final provocative thought for you to mull over as you watch this future gallop closer.
Go on.
The choice of hydrogen is key to its performance, but it also creates this total reliance on an infrastructure that doesn't really exist yet, especially not in remote areas.
Right.
So beyond the cost and the technical challenges, what are the practical, real-world regulatory and safety hurdles for setting up hydrogen refueling stations to support these decentralized herds in off-road adventure zones by 2035? That logistical reality is something worth thinking about.
A great point on which to end. Until next time, keep digging into those sources.